Welcome to the Explainer. Today, we're diving into a pretty revolutionary way to store energy. And get this, forget about rare earth minerals, because this solution relies on something that's all around us.
I mean, just think about that question for a second. What if we could store massive amounts of energy using the very air we breathe? It sounds a little bit like science fiction, right? But it's a very real technology called cryogenic energy storage. So to really get why a technology like this is so important, we have to start with a fundamental problem, a huge challenge that our modern energy grid is facing right now. Look, we all love renewables, but the sun doesn't always shine and the wind doesn't always blow. It's just a fact. And this creates this massive gap. We generate tons of power on a sunny, windy afternoon, but we really need that power on a calm, dark evening. And if you can't store it, all that energy just disappears. It's completely wasted.
Now, I know what you're thinking. What about batteries? And yeah, you're right. Lithium-ion is absolutely fantastic for short-term storage. It's in your phone, it's in electric cars, but trying to scale it up to power entire cities for days on end, that is incredibly expensive, and it takes a massive amount of mined resources. It's a piece of the puzzle for sure, but it's not the whole answer for the grid. And this is where things get really, really cool. Instead of looking for another chemical solution, some very smart engineers started looking at a physical one. They started looking at the atmosphere itself as a kind of giant rechargeable battery. And here it is, the core idea: cryogenic energy storage. You might also hear it called liquid air energy storage, or LAES for short. The process is pretty mind-blowing. You take regular old air, you get it incredibly cold. We are talking minus 196 degrees Celsius, and at that temperature, it actually turns into a liquid. And in that liquid state, it's holding a massive amount of potential energy. So here's the secret sauce. The magic isn't in some complex chemical reaction. Nope, it's all about physics. It's a radical physical transformation, a truly massive change in volume.
And this says it all. We're talking about an expansion of 700 times. Let me tell you what that really means. So when that super cold liquid air starts to warm up, it expands with just incredible force. A single liter of liquid instantly becomes 700 liters of gas. And if you can channel that almost explosive expansion through a turbine, well, you can generate electricity on demand whenever you need it. Okay, so let's get into the nuts and bolts here. How do you actually build a plant that turns thin air into a battery? It's a surprisingly simple and, elegant cycle. It all happens in 3 basic stages. First, when you have way too much power, from solar panels at noon, you use that excess electricity to run an air liquefier. That's the charging phase. Second, you just store that liquid air in what's basically a giant thermos, a cryotank. And third, whenever you need that power back, you just let the liquid warm up, expand like crazy, and spin a turbine. Charge, store, recover. Simple as that. Now, you should know this isn't just some concept on a whiteboard. A company has taken this technology from small pilot projects to full-blown grid-scale power plants that are happening right now. The company really leading the charge here is called Highview Power. They're based in the UK, and they built a successful pilot plant that proved this whole concept could work in the real world, actually hooked up to a modern grid. And here's one of the best things about this technology. There's basically no science risk. What does that mean? It means the compressors, the tanks, the turbines, these are all standard industrial parts that we've been using for over a century. We already know how to build them, we know they're reliable, and the supply chains are already there. And here's another key benefit, and it's a bit technical but super important. Because it uses a big physical spinning turbine, it provides something called synchronous inertia. Just think of it like a giant mechanical shock absorber for the grid. It helps keep everything stable. It's the same stabilizing effect you get from old coal or gas plants, and it's something chemical batteries really struggle to replicate. All right, so how does liquid air actually stack up against the other big energy storage technologies out there? Let's put them head to head. Let's start with longevity, because this is a huge one. A liquid air plant is built to last over 35 years, maybe even longer. A large-scale lithium-ion battery farm, you're probably going to need to replace those cells every 10 years or so. That is a massive difference in cost and resources over the lifetime of a project. And the advantages just keep stacking up. Unlike pumped hydro storage, which needs a mountain and a valley, you can build these things practically anywhere. They use no toxic materials, which makes them incredibly safe. And maybe most crucially, they don't degrade. A liquid air plant can store the exact same amount of energy on its 10,000th cycle as it did on its very first.
But, and this is an important but, there is a trade-off. It's called round-trip efficiency. Basically, that's how much energy you get back for every unit of energy you put in. For liquid air, it's hovering around 60%. Lithium-ion batteries, on the other hand, are way up there, closer to 90%. This table kind of puts it all in perspective. You can think of lithium as the sprinter. It's amazing for a quick burst of power. Pumped hydro is the marathon runner, but it can only run in the mountains. Liquid air fits right there in the middle. It's a long-duration solution that you can build anywhere, and it gives you that critical grid stability we talked about.
So you might be asking, why is that lower efficiency okay? Well, because when your goal is to store enormous amounts of energy for days or even weeks, the cost of your storage medium suddenly becomes the most important factor. And for a liquid air plant, the storage medium is, well, it's air. It's free. And that completely changes the entire economic equation. So here's the bottom line. We're going to need a mix of all these technologies. Lithium-ion will handle the split-second and minute-to-minute changes. Maybe something like green hydrogen will handle storing energy for months and across seasons. But for that really critical gap, storing huge amounts of energy for hours and days on end, liquid air is perfectly positioned to become the mechanical backbone of a renewable grid. And that leaves us with one final thought. You know, for decades, the cooling tower was the symbol of our energy system. As we look to the future, could its replacement be a quiet, unassuming, insulated silo holding the cold, dense potential of liquid air? It's a pretty powerful vision for a cleaner energy future.